So I'll put up the, if you answer correctly, I'll put up the screen again so you can pick the next question. If you answer incorrectly, we'll just pass it to someone else so they can answer. So I would rather you try to answer and get it wrong than to just sit back and let everybody else answer. Because at this point, you need to be trying to come up with answers on your own. That's what makes it active. Okay, if you're sitting back and waiting for other people to answer, it's passive. And this close to the exam, you really need to be working actively. Okay, Esmeralda, you have a question?
Yeah, can I also record too?
Yeah.
Thank you guys for recording. This helps a lot.
Okay.
No problem.
Okay, so I'm sorry I can't throw candy at you, but you can pat yourself on the back if you answer a question. Even if you can get it wrong, pat yourself on the back for attempting to answer a question, because that's a good thing. Okay. And so the other thing we'll do is when a drawing comes up, I have it enabled so you guys can share your screen. So if someone wants to draw, for example, the hemoglobin saturation curve or anything else that we need to be drawing, the lung volume chart, if you go down right next to where it says manage participants, there's a button for share screen. You click on that, you click on the whiteboard, and then you can draw on the whiteboard and everyone will see it. So we'll get to do some of that. Okay. So I will start. Okay. I will start with cardiovascular system 3. Okay, this is explain the cardiac autoconduction system. Explain the cardiac autoconduction system. Eddie, go ahead.
So it starts from the SA node. At that point, that's where the initiation of contraction begins, of the electrical signal. It also sets the natural sinus rhythm to 100 beats per minute, and it contracts both of the atria. From there, the signal is conducted down to the AV node, which slows down the signal so that the ventricles can finish filling and to prevent co-contraction with the atria. From there, it's conducted through the AV bundle or bundle of His, and it makes its way down to the Purkinje fibers, which is contraction of the ventricles.
Perfect. So another word for that would be intrinsic control of heart rate. Okay, so this time I used cardiac autoconduction. I could also ask the same question by asking you to explain intrinsic control of heart rate. It would be the same answer. Okay, let me know if you have a question. Otherwise, Eddie, you can pick the next one.
Let's do, how about energy expenditure and fatigue for 4?
What is the main source of fatigue in a 3-hour marathon run? There should be a lot of hands up on this. Main cause of fatigue in a 3-hour marathon run. Jasmine.
Glycogen depletion, since you only have stores for up to 2 hours.
Mm-hmm. Very good. And Jasmine, you can pick.
Numbers and calculations for 5.
Okay, so this one is counting up oxygen molecules and carbon dioxide molecules, which you don't need to do. And that's also number 6. So, okay, please pick a different one.
Graphs and charts for 4.
Okay, draw and explain a graph of lactate threshold. Draw and explain a graph of lactate threshold. So someone can try to do drawings on their whiteboard like I've been doing. Esmeralda, go ahead. So she's going to put up her whiteboard, and you guys on your own paper can practice drawing your lactate threshold and think about how you would define it. Oh. You're actually making your lines straight. I don't even know how to do it that way.
Ah,
That's interesting. How are you doing that? Oh, I see how you do that. I've never tried that before. I've never gone beyond just drawing. That's cool.
so you have low, medium, and then high. So, and then I forgot which one goes here. So lactic threshold is the point at which lactic acid begins to accumulate as intensity increases.
Mm-hmm.
You also have here, somewhere in here, that would be like the point of lactic threshold.
Mhm.
And that's when like you hit high intensity and your lactate threshold goes up.
Well, your lactate threshold is not going up. Your lactate levels are going up.
Yes.
Lactate threshold is not going up. Okay. Okay, good. What's the benefit of having a high lactate threshold?
Lower fatigue, or you fatigue at a later point.
Later point meaning after 40 minutes instead of after 20 minutes? Or what do you mean by later point?
Yes. So
Jasmine, can you explain what is the benefit of having a high lactate threshold?
If you have a higher lactate threshold, then you can work out at a higher intensity or reach your lactate threshold at a higher intensity as well.
Which means you can maintain a higher intensity for a longer period of time. So if you hit your lactate threshold at 5 miles per hour, then that's about the speed you can maintain for an extended period of time. You wouldn't be able to maintain 6 miles per hour if you hit your lactate threshold at 5. But if you increase your lactate threshold and you don't hit it till 6 miles per hour, now you can maintain 6 miles per hour. So Esmeralda, the way you were saying it was like before when the person has a low lactate threshold, they can maintain 5 miles per hour for 20 minutes. When they increase their lactate threshold, they can maintain that same 5 miles per hour for 40 minutes. That's not what the lactate threshold does. Lactate threshold makes it so you can exercise at a higher intensity and still be aerobic, so that you can maintain that intensity for longer. Okay, questions on that? Okay, I have a separate question on how we go about increasing our lactate threshold, so I'll wait till we hit that question for that. Okay, Esmeralda, you can pick.
Respiratory system for 6.
Draw and explain the Bohr effect. Draw and explain the Bohr effect. Nicole, is your hand up for that? Oh, put your hand down. I didn't think so. Okay, draw and explain the Bohr effect. Anyone else besides Esmeralda? Who else has their hand up? Eddie, go ahead.
Okay.
Share screen, whiteboard. Okay. So.
Close door, close door.
Okay. Oh.
Ethan, wait for me.
It doesn't have to be neat.
Oh, okay, because I'm like having a hard time doing this.
Yeah, you can just do it with the drawing tool.
All right. So we go down like this,
I'm fine with
go
that.
down this way, and low, medium, high. Low, medium, high also here. So on this side, we're concerned with, was this, wait, this was hemoglobin saturation, I think.
We're drawing the Bohr effect.
Yeah, we're doing the, wait.
Oh yeah, so what goes on the y-axis?
Hemoglobin saturation?
Yeah, it should be percent hemoglobin saturation.
Oh,
Yeah.
percent, thank you. Now here was, I actually forgot what goes down on the bottom. I remember what the graph looks like, but.
And somebody help him, what goes on the x-axis?
Partial pressure of oxygen.
CO2.
VO2?
PO2.
P.
PO2, partial pressure. of
Oh,
oxygen.
right. PO2. And then so as far as drawing, when we're at normal pH, it would be something like this. Right, that's normal pH, but then for lower pH, hemoglobin saturation drops off more quickly, more readily to deliver oxygen into the exercising muscle. So this one's low pH, and this one is normal pH.
Good. Yeah, so you mentioned everything you need to mention. So the drawing is great. So basically this is saying the low pH is causing the low hemoglobin saturation. That's important because the pH is low at the exercising muscle. So this means that when hemoglobin arrives at the exercising muscle, it releases oxygen. Very good. So on the test, you will not have the ability to draw. So you won't have to worry about drawing it, but you will have to be ready to explain it. Okay. Any questions on that?
I had a question.
Go ahead.
So is that how it's gonna be for all the graphs and drawings you gave us? We're just gonna be explaining them?
There will be nothing for you to draw on this test. There's not a whiteboard function like that on Canvas for you guys to be able to draw.
But you said we need to explain the importance and what the graph says, right?
Yeah, so I could ask you to, so this question was draw and explain the Bohr effect. So this would just be explain the Bohr effect. So you would just have to say the Bohr effect says that a decrease in pH will cause decreased hemoglobin saturation. That's important because pH is low at the exercising muscle. Therefore, hemoglobin will release its oxygen at the exercising muscle. Yeah.
Okay.
So it's everything the same except without the drawing.
Okay.
Okay, Eddie, you can pick.
How about let's do the grab bag for 2.
What is a cardiac cycle? What is a cardiac cycle?
Could I go?
Got Svetlana, go ahead.
Is it everything that occurs during one heartbeat?
Yes.
There's diastole, which is the atria is contracting and the relaxed, and then systole would be the atria is relaxed and filling, and the ventricles are contracting and emptying out.
Yeah, perfect. Yep, go ahead and pick.
Do you want that much detail in the answer?
You'd have to at least mention everything that occurs in one heartbeat, mention diastole and systole. The definition of diastole and systole would probably come in a different question, but I would hopefully make it clear whether or not you need to give that much detail. I'm not trying to be unclear, so that's the type of thing, if you're not sure, you can ask how much information you need to give there, but I'm trying to make it pretty clear. Okay, Svetlana, go ahead and pick.
Energy expenditure and fatigue 7.
Okay, what is the best predictor of endurance performance in an untrained population and a trained population? Jasmine.
For someone who's untrained, you would look at their VO2 max. If for someone who's trained, you would look at their lactate threshold. But if you have two athletes that have the same lactate threshold, same VO2 max, you would then look at the economy of effort, which is their form.
Perfect. Yeah. Good job. Okay, go ahead and pick.
Grab bag for 6.
What is sympatholysis? Sympatholysis. Caroline.
Isn't it when the arterioles can still vasodilate instead of vasoconstrict, despite even though epinephrine is being released?
Yeah, that's a good answer. I like that. Good. Go ahead and pick.
Can we do cardiovascular system 7?
Okay, describe arterial autoregulation. Describe arterial autoregulation. Ariel, go ahead.
It's where the arterioles regulate themselves through the control.
More detail, please.
The intrinsic control would be would it be the peripheral resistance? No.
Nope. Svetlana, do you want to answer this one?
Yeah, so for intrinsic control of heart rate, you would want to be vasodilating and
This is blood flow, not heart rate.
wait, what?
You said intrinsic control of heart rate.
Heart rate?
This is intrinsic control of blood flow. You said heart rate, but you meant blood flow.
Oh, sorry, blood flow. It's vasodilation, and there are some local conditions at the exercising muscle. To do that, it would be you have a decrease in oxygen because the muscle is consuming that oxygen, an increase in carbon dioxide because it's a byproduct of the bicarbonate buffer, and you get a decrease in pH from the hydrogen from the lactic acid, which is also, you get an increase in that, and the hydrogen ion, and you get an increase in temperature because muscles produce heat. And then with that, your chemoreceptors will sense that, triggering vasodilation, increasing your blood flow, which will normalize your pH, decrease your lactic acid, your hydrogen ions, your CO2, and decrease your temperature. Yeah.
Yeah, that's great. So the original question was explain arterial autoregulation. So you understand that arterial autoregulation and intrinsic control of blood flow are the same thing. You're talking about how the arterioles control themselves. So we talked about that with the arterioles being able to vasodilate. So that at the exercising muscle, you have those local conditions sensed by the chemoreceptors triggering vasodilation. So everybody understand that that's the answer I was looking for? You understand what I was asking for? Okay, awesome. Svetlana, you can pick.
Let's do respiratory 7.
What happens to AVO2 difference as exercise intensity increases and why? what happens to AVO2 difference as exercise intensity increases. That was one of the last things we talked about. Tatiana, go ahead.
It's when the exercise intensity increases, the amount of oxygen brought to the muscle will be the same, but the AVO2 difference will increase because the more of the oxygen the muscles are consuming, the bigger the difference will be between the amount of oxygen in the arteries and the amount of oxygen in the veins.
Perfect. Awesome. Any questions about that one? Okay, Tatiana, you can pick.
Let's do cardiovascular system for 5.
Name 3 things that can cause an increase in peripheral resistance. 3 things that can cause an increase in peripheral resistance. Let's see. 3 people with their hand up. Esmeralda, go ahead.
Increase in cardiac output, increase in stroke volume, or increase in radius of the vessel?
Not quite. Peripheral resistance does not depend on cardiac output. Tatiana, do you want to do this one?
Sure. Is it increase in length of the vessel, an increase in the viscosity of the blood, and a decrease in the radius of the blood vessel?
Yes. So to talk about what's happening in peripheral resistance, you need to look at the formula for peripheral resistance. Anything that's going to affect peripheral resistance has to be in that formula. Okay, so the cardiac output is part of the formula of blood pressure, but it's not part of the formula of peripheral resistance.
Professor, do we have to include that the way that you increase the length of the vessels, gain weight, and increasing viscosity is dehydration? Okay.
Okay, Tatiana, you can pick.
So respiratory for 4.
Okay, Boyle's law, Henry's law, Dalton's law, and Fick's law. Is there anyone who can do all 4, or we can go one by one? Without reading it from your notes would be preferred. Svetlana, go ahead.
Boyle's law is the inverse relationship between pressure and volume. Dalton's law is the total pressure is equal to the sum of the partial pressures. Fick's law would be the rate of diffusion is proportional to the surface area and the gas gradient. And
Henry's law.
Henry's law would be diffusion of liquid is proportional to the partial pressure gas gradient.
Yes, gases dissolve in liquid in proportion to their partial pressure. Yeah, very good. All right, you can pick.
Let's do grab bag 7.
You guys are avoiding those 8s. What is oxygen deficit? This is an easy one. There should be a lot of hands up. What is oxygen deficit? Lewis.
Oxygen deficit is when your body, you don't have the necessary amount of oxygen that your body needs to do a certain action or exercise.
Yeah, very good. So oxygen consumption is lower than the oxygen requirement. You're not getting enough oxygen. Perfect. Go ahead and pick.
I'll go with cardiovascular for 8.
Awesome. Okay, name 3 venous return mechanisms. You don't have to explain them, just name them. 3 venous return mechanisms. Ismail. You need to unmute yourself.
Sorry. So vasoconstriction, the muscular respiratory pump, and the Or I think I mixed them. I'm sorry. Is the respiratory pump
Mm-hmm.
and the muscular? I'm missing the word in between.
It's the skeletal muscle pump.
Pump.
Skeletal muscle.
Skeletal muscle.
Yes, and that
Okay.
brings up something important because some of the questions are fill-in, where you have to type in the word. If you don't type in the word exactly the way I type in the word, it's going to mark it wrong, which means spelling is going to be important. So if you were to put muscular pump, and I put in skeletal muscle pump, it's going to be counted wrong.
Right. Okay.
Okay, so make sure on the fill-ins that, and I try to only use fill-ins on like terminology where it's really just checking your spelling. Okay, but make sure you study your spelling because it will count on those kinds of questions.
Good. Thank you.
Okay, are any of those hands up because you have questions, or were those hands up to answer? You can put your hands down if you don't have a question. Okay, Ismail, go ahead and pick.
Okay. Let's do numbers and calculations for 4.
Okay, I need the formulas, the equations for stroke volume, cardiac output, ejection fraction, blood pressure, hematocrit, and RER. Anybody want to try to do all of them? Ismail, is your hand up for this one?
No, sorry.
Okay, let's see who else is hand up. Rosie, start with stroke volume.
Can you hear me?
Mm-hmm.
Okay, so stroke volume equals end diastolic volume minus end systolic volume.
Good. Cardiac output?
Cardiac output equals heart rate times stroke volume.
Good. Ejection fraction?
Ejection fraction is, I don't know if I'm right, stroke volume divided by end diastolic volume.
Times 100.
Yeah.
Blood pressure?
Blood pressure, do you want both? Or just?
You can give me, the short formula and the expanded formula. It's a good idea.
Okay, so short is blood pressure equals cardiac output times peripheral resistance. And then the extended is blood pressure equals heart rate times stroke volume times length times viscosity divided by radius 4.
Hematocrit?
That one I'm not too sure of.
Okay, RER?
RER is equals VO2. No, wait. VCO2 over VO2?
Good. London, do you have the hematocrit one?
Formed elements divided by
Remember to get it, it's percentage basically, right? What percentage of the blood is formed elements? So it's going to be the formed elements divided by the total amount. What's that called?
Yeah, okay.
Total
amount of.
Esmeralda's yelling at you.
Oh, she is. Oh, I see.
Total
amount of blood volume? No.
Yeah, total blood volume, yeah.
Oh, okay. Okay, I'm overthinking.
Yeah, formed elements divided by total blood volume.
Okay, yeah.
Good. Yeah, make sure you guys know those formulas.
That's right. I have a question.
Go ahead.
For the actual test we take, are we allowed to write EDV for end diastolic volume, or do we have to spell it out?
You have to spell it out. And you have to spell it correctly.
Okay.
Okay, Rosie, you can pick. I suggest you guys start picking some 8s.
Energy expenditure and fatigue 8.
Okay, name a limitation of direct calorimetry and a limitation of indirect calorimetry, and explain what those are. Tatiana, go ahead.
For direct, right?
For both.
Oh, shoot, okay.
You can start with direct. We can have someone else do indirect.
Okay, so for all direct, there's you're running on a treadmill and you have it's kind of weird to explain. There's like the two.
You don't have to explain the whole thing. Just tell me what we're measuring. The direct calorimetry measures what?
Oh, it's measuring the heat produced.
Okay, and what's the major limitation?
The heat being produced from the treadmill can alter results.
Okay. And do you want to pass indirect to someone else?
Sure.
Okay, Eddie?
Indirect, you're measuring VO2, and the limitations for that is firstly that it's an estimate, so it's not as accurate as the direct calorimetry, and also it's less accurate at high intensities because it doesn't take into account the non-metabolic CO2.
Non-metabolic CO2 coming from where?
From the bicarbonate buffer.
Good. So I wouldn't say it's less accurate than direct calorimetry. I mean, theoretically, because you're not measuring heat directly, but that measurement for direct calorimetry has more problems than indirect calorimetry. That's why we use indirect calorimetry and not direct, because it's actually better, even though it is an estimate, it's actually better. And it's measuring, indirect calorimetry does not just measure oxygen consumption. It measures oxygen consumption and carbon dioxide production, which is where we get the RER from. Okay, so that's why the excess carbon dioxide from the bicarbonate buffer throws off that RER, because it's more carbon dioxide than is expected. So that's going to affect our caloric equivalent, which makes our calculation less accurate.
Would you mind just clarifying then? So you said there's 2 limitations, and I feel like
You only needed to give one.
Oh,
The main one I'm looking for is the excess carbon dioxide that's not accounted for at high intensities. So the calculation assumes that the carbon dioxide is coming from the metabolic system. So it assumes that you're working aerobically. So the more of an anaerobic contribution there is, the less accurate our calculation is.
Cool.
Can you quickly let us know what the second limitation of indirect calorimetry is?
You could say that it's expensive, it requires a lab and a technician. I'm mainly concerned with the carbon dioxide one. Okay, Tatiana, that was you that started this, right? You can pick.
Oh, okay. Let's do respiratory for 8.
What is inspiratory capacity minus inspiratory reserve volume? Inspiratory capacity minus inspiratory reserve volume. Think about that curve. Luciano? Did you not mean to raise your hand? I can't hear you. Okay. Who else has their hand up? Put your hands back up. Cindy.
Is it tidal volume?
It is. Inspiratory capacity minus inspiratory reserve volume is tidal volume. Okay, there's another question on here that'll have us drawing the graph, so I'll wait till we get to that to go over it. Cindy, you can pick.
I'll do numbers and calculations for 8.
Yay. Okay, so this one is a calculation. So what we discovered in the last class is I can write it up here. Oh, let's clear that. Here, there's what I'll do. I'll write it up here, but some people were able to annotate this and some people were not. So let's do this. VO2 max is 57 mLs per kg per minute. The weight is 192 pounds. I want you to calculate energy expenditure for 30 minutes at 60% of VO2 max. Okay, so I want to point out that it is possible to write out your work like this. Okay, so you could do the 57 mLs per kg per minute times the 0.6. You can write out, you know, the 57 mLs per kg per minute times whatever the kilograms are divided by 1,000. You can write that all out on here. But the questions I put on the test, I'm not going to be grading your work. I'm only going to be grading your answer. Okay, so you're not going to have to worry about that at this point. But for now, whoever is going to do this right now, I want you to write it out to make sure that everybody knows how to do it. Okay, so in order to do this, what you do is you click on annotate, and then it'll allow you to write on my whiteboard. Okay, so who wants to do that? Somebody's got to do it. Brianna, you want to do that?
I can try it.
Okay, so I will put that whiteboard back up. You should be able to click on annotate. And I think what happens, what we discovered in my earlier class, is that it doesn't show up while you're typing, but after you click outside your box, then it shows up on the screen. So
Okay,
try that real quick and make sure it's going to work. And everybody else on your own piece of paper, calculate an answer for this.
Sorry, do I go to share screen or what?
It's up at the top where it says view options. The drop down menu
Oh,
should have annotate.
Yes, thank you.
Okay.
We're going to go ahead and click outside your box so we can make sure that your writing is going to show up on here. Okay, perfect. Thank you.
Okay. Should I just keep adding to it?
I'm not sure you can add to it once you've done out of it, but
Okay,
just
I'll
put a
try it
box
on the
next to
next
it and continue.
Okay.
If you have a question, you can just jump in. I can't see whose hands are raised.
Let's see.
Oh, Professor,
Mm-hmm.
we can use an actual calculator, right? Not our phones.
Right, you can't use your phone, but you can use a calculator. There is also a calculator available on the lockdown browser,
Okay,
but you can use your own calculator. Your phone will be used for Zoom.
right.
So you'll be on your computer or your laptop to take the exam, and then you'll have your phone on with Zoom. So we'll be like this so that I can see you guys and so you can ask me questions.
Okay.
Can we have scratch paper?
You can have blank scratch paper. You cannot have notes with you, but you can have blank scratch paper. For doing the math and for like writing out that big blood pressure map. Those are the main things I think you'll need it for. Okay, so we've got the 57 times the kilograms times 5 divided by 1,000 times 30 minutes times 0.6. Okay, so the order is a little weird, but that won't matter as long as you have them all in there. 447. Good. Did everybody else get that answer?
Yes.
Okay, so your answer on the test, when you do this, I'm only giving you a spot for a numerical answer, so you won't even be able to type in your units. It'll literally just be the number. Okay, so what I'm doing is I will give it the number that I get for the answer, and then I'm accepting values within a certain range of that. So if you're rounding slightly differently than I am, you should be okay as long as you're within a reasonable range of this answer. If you've done something completely wrong, you got the wrong answer, there won't be partial credit because I'm not grading your work. Okay, but it won't be worth as much as if I was offering partial credit. Okay, any questions on
Are
that?
we gonna have like short answer where it's like more than one sentence questions?
Yes. So I was going to talk about this after we're done with the Jeopardy questions. I'll give you more detail on what the exam's going to be like. Let's get some more questions in here first. I'll talk about the partial credit. Olivia, I see your question. I'll talk about that after we've done Jeopardy. Where's my Jeopardy? Here. Okay, who was doing this? Brianna?
Yeah.
You can go ahead and pick.
Let's do grab bag for 8.
Okay, explain 3 ways hydrogen causes fatigue. Let's see whose hands are up. Eddie, go ahead and do it. 3 ways hydrogen causes fatigue.
Hydrogen accumulation lowers pH, which inhibits PFK. That slows down glycolysis, so we produce less ATP. That makes it so that we can't release our cross bridges, so there's less power strokes and therefore less muscle contraction.
Okay.
The second part of that is that the lowered pH also inhibits glycogen phosphorylase. So glycogenolysis slows down. We produce less glucose, so there's less G6P, which then goes on to inhibit PFK. So there's less ATP being produced, like glycolysis slows down, less ATP is being produced, less cross-bridging and power strokes and muscle contractions. And then the increased hydrogen has to do with competitive inhibition. So the troponin has a greater affinity for hydrogen than for calcium ions. So it'll prevent the calcium from binding to troponin, so it won't pull tropomyosin off of the actin sites. No cross bridges will form, less power strokes, and and reduced muscle contraction.
So this would be an example of a short answer question where you'll just have a box and you'll have to type in that complete answer. Okay, I will tell you I'm less likely to just ask you to explain 3 ways hydrogen causes fatigue. I'm more likely to make it a little bit more applied, and I'll give you an example of this person is doing this activity, what are their causes of fatigue? This person is doing this activity, what are their causes of fatigue? So you would have to determine what system they're in and then explain the causes of fatigue in that system. So it's just the same question, but slightly more applied. Okay. Eddie, you can pick.
Cool. Let's do the last 8 there. What is that? Graphs and charts and maps?
Mm-hmm. Okay, how do baroreceptors cause an increase in blood pressure during exercise? Draw a map. Okay, so what we did on this one in my earlier class is we had 2 people working on it. So one person can do the PNS side and the other person can do the SNS side. If someone wants to share their whiteboard, and then the second person can annotate. Okay, so can we have 2 volunteers for this one? Okay, Svetlana, go ahead and share your whiteboard. And then Tatiana, if you want to do the other side of it, you guys can discuss who's going to do what.
I'll do the right side of it.
The SNS?
Yeah.
Okay, so everybody else should take out a piece of paper and practice drawing this. So we already know you will not have to draw this. I will not be grading you on drawing this on the exam, but there will be questions on there that I guarantee you'll want to have be able to draw this to help you answer the question. You cannot bring it with you already drawn, but you can have blank piece of paper and draw it from memory. So I'll go in and draw the arrows. If you guys want to just put in the words,
would you please?
Then we can get this through this a little faster. Challenging, yeah.
Whatever.
Yeah, it's fine. It doesn't have to be lined up. We understand.
And then I would have to do, I'm doing the parasympathetic nervous system.
So Svetlana, you're doing parasympathetic, and Tatiana, you're doing sympathetic?
Right.
Okay. This is kind of fun to collaborate on this. Remember that on the test, you will not be able to abbreviate these things.
Yeah.
So you'll have to write them out and spell them correctly. We're missing something in between vagal tone and heart rate.
PSA node.
Oh yeah. Yeah, there we go, that'll work. Arterials, an effector. Left ventricular myocardium is an effector. 1, 2, oh, that's good. Okay, that looks great. So you guys understand how to use this. I could ask you to explain the parasympathetic nervous system's involvement in increases in blood pressure. Parasympathetic, so this needs to be fixed, but that's okay. I could ask you to explain how epinephrine is involved in increasing blood pressure during exercise. Or I could ask you about the sympathetic nervous system in general, and you'd have to include the sympathetic cardiac nerve. I could ask you what's acting on the SA node to cause increases in blood pressure and how that works. So I could ask you a lot of questions that will involve the use of this map in order to give me all the details of the process. Okay, that looks great. Any questions on that one? Good. Okay, let's do Svetlana, you can pick. Let's do charts and graphs. 7.
Did you say a number?
Yeah, 7.
Charts, graphs, 7. Draw and label the graph for the rest to exercise transition. That'll be a fun one. The rest to exercise transition. It's fun to use the whiteboard. Nicole, go ahead.
This is, just to clarify, this is the one with the PNS, or parasympathetic and sympathetic nervous system, right?
Not the rest to exercise transition. This is the one with steady state and oxygen deficit and EPOC.
Oh,
Yeah.
I could do that too.
Okay.
I'll try.
You don't have to write in the words, just kind of draw the curves and then you can talk us through it.
Okay. Wait, sorry, how do I?
Click on share screen and then whiteboard.
Okay. Oh my gosh.
It's okay.
So bad.
Now I know what it looks like when I do my silly drawings.
Oh my God, I'm so sorry.
It's okay.
Can I type it?
Change color. If you click on format with that little colored box, you can switch to a different color. But you need to click on the draw again. I mean, you can click on something else.
Oh my gosh.
Click on draw and then the little squiggly line.
I don't even see that anymore.
I don't know what you clicked on.
I don't either.
You don't see the little toolbar anymore?
No.
There's a little thing up top that says whiteboard. Just hit that.
Oh, okay. Okay, got it.
Thank you.
Thank you. Oh, okay.
Oh, this is very entertaining.
Okay, you get the point for there.
Yes.
And then this over here is steady state, which is all the way on that side, if that makes sense.
Yeah. If you press enter, it'll go underneath there.
And then this is starting exercise.
Okay, so you don't have to type in the words, just
Okay.
Tell us.
And then on this side will be ending exercise. And then in this area here, it's so here you're meeting your oxygen requirement and your oxygen consumption, and then let's say you get up and you start exercising, your oxygen requirement is gonna require more than what you're consuming.
Okay, so what's that called?
Oxygen deficit.
That's it. Okay.
And then here it's supposed to be sort of steady, and then let's say you end your exercise, the oxygen requirement is greater than what you're consuming. No?
No, which of these lines is requirement?
Requirement. The pink one. Oh, no, the black lines.
The black one is requirement.
That's the requirement, yeah.
Okay, so the requirement here is lower than the consumption. So this is when you're still consuming a lot of oxygen even after you've stopped exercising.
Yes.
Okay, so what's that called? Excess.
Oh, epoch.
Yeah. And what does that stand for?
So, excess post-oxygen consumption.
Post-exercise. Yes, excess post-exercise oxygen consumption. Good. What goes on the x-axis here?
Exercise intensity.
This is not increasing intensity. It's actually increasing intensity as you go up this way.
Oxygen requirement.
So oxygen goes over here. This one is just time passing.
Okay.
So this is, you're sitting down for a couple of minutes, and then you're exercising for a couple of minutes, and then you're sitting down. Okay, so this is time passing. As you increase your intensity, this is where you're starting the exercise. Get rid of that box. I can't. Is that box yours?
Yeah, sorry.
Okay, so then this is where you're ending the exercise. Okay, so if we were drawing this by hand, I would expect it to be a little bit more precise on making the steady state here, but I understand it's not that easy to draw with this. And then you'd reach a steady state here at the end again. So with this, obviously you're not going to be drawing it on the test. I still want you to practice drawing it because it is something you need for 446. But main thing I want you to understand here is oxygen deficit, be able to define it, steady state, be able to define it, epoch, be able to define it in terms of the relationship between oxygen requirement and oxygen consumption. Okay, the 4 things that are occurring during epoch, for this review, I have in a separate question.
Okay.
Okay, good, thank you for that. Anybody have any questions on that one?
Can you repeat which ones need defined? You said steady state, epoch.
Steady state, epoch, and oxygen deficit.
Steady state wasn't like where it was when she drew it, right? Where she had the words like steady state. It's all the way at the top, right? Not
So
like
you're in steady state at rest, and you can be in steady state during exercise. So, because either way, your oxygen requirement is being met. We're mostly concerned with steady state during exercise. But on that graph, there are actually 3 places where you're in steady state. At rest before you exercise, during the exercise, and then after your epoch finishes, you're back at steady state.
Okay.
But yes, I am more concerned with the steady state that's during the exercise. Steady state, aerobic or anaerobic?
Aerobic?
Aerobic. You cannot be in steady state if you're working anaerobically, because the definition of steady state is that oxygen consumption is equaling oxygen requirement, which does not happen if you're working anaerobically. Okay, oxygen deficit, aerobic or anaerobic?
Anaerobic.
Anaerobic.
Anaerobic, because you're not getting enough oxygen. Therefore, by definition, you're working anaerobically. Good. Nicole, you can pick.
Energy expenditure and fatigue for 6.
Oh, there it is. 4 main purposes of epoch. Should be a lot of hands up on this one, guys. Don't let the same 3 people answer all your questions. This should be an easy one. 4 things that are occurring during epoch. Brianna, go ahead, please.
Restoring blood restoring body temperature, replenish ATP storage, replenish oxygen, and then clearing lactic acid.
Very good. Good, you can pick.
Let's do cardiovascular for 6.
For 6. Explain extrinsic control of blood flow. Extrinsic control of blood flow. This isn't also an easy one. There should be a lot of hands up. Extrinsic control of blood flow. Oh, yay. Ariel.
Epinephrine will cause vasoconstriction.
Yep. At the arterioles. You mentioned the arterioles.
Yeah.
Okay, good. You can pick.
Grab bag for 5.
What is included in the respiratory membrane? London.
Is it the partial pressure and the oxygen, how it go and
That's explaining pulmonary diffusion, which involves the respiratory membrane, but I want to know the 4 parts of the respiratory membrane.
or partial?
Can you repeat the question?
Yes. What are the parts of the respiratory membrane? Ismail, go ahead.
So it's the alveolar wall, the alveolar, the capillary wall, and at the bottom is the basement alveolar, and the
Basement membrane, the alveolar basement membrane.
and the capillary basement or alveolar I'm getting all messed up, I'm sorry.
Capillary basement membrane. So we have the respiratory membrane is where the gas exchange takes place between the alveoli and the capillary. So the alveoli and the capillary each have their own wall, and then the alveoli and the capillary each have their own membrane. And they're called basement membranes. So we have the alveolar wall, and then we have the alveolar basement membrane. We have the capillary wall, and we have the capillary basement membrane. Those 4 parts together make up the respiratory membrane, and that's what the gases have to diffuse across.
Okay.
Okay.
Thank you.
Ismail, you can pick. 10 more minutes.
No more 8s, right? So let's do the last 7.
Calculations for 7. No, I don't have a good one there. Sorry. Let's do graphs, charts, and maps for 6. Okay, draw and label a graph of lung volumes. Draw and label a graph of lung volumes. London. Can you put up your whiteboard?
How do you do that again? I'm sorry.
So click on share screen and then click on whiteboard.
Where is on the bottom of my computer it says invite participants and then it says share.
Yeah, share screen.
Okay.
And then whiteboard.
Zoom in. Context. Right there. I'll get this. Give me 1 second. I don't see share screen. Share whiteboard on here. I see desktop. It says, "What do you want to share?"
Yeah, one of the options is whiteboard. When that window opens up, just hit whiteboard and then hit OK on the bottom right.
I don't see that. It only says desktop and application. What do you want to share? Desktop application. I don't know what that means.
I don't know why that is.
There should be a whiteboard.
Yeah, there should be a whiteboard. That's okay. We'll pass it to someone else just because we're limited on time. Let me see who else has their hand up. Esmeralda, go ahead, please.
I don't know.
So everybody else should take out a piece of paper and practice drawing this. Lung volumes. So on the test, you won't have to actually draw this, but answering questions about the lung volumes will be easier if you can draw this. Good. And you can just point and talk us through these. You don't have to write it all out. So can you tell us what they are as you're drawing the arrows, please? I can't hear you if you're talking.
So tidal volume is the amount of air you breathe
During a normal breath.
Then you have inspiratory capacity here, which is tidal volume plus inspiratory reserve volume. Then you have this one. This expiratory reserve volume.
That's not expiratory reserve volume.
Vital capacity.
Vital capacity, which is
inspiratory capacity plus expiratory reserve volume.
Okay. In words, it would be the maximum amount of air you can move through your lungs in one breath. Vital capacity. Okay, go ahead.
That's expiratory reserve capacity? No.
No, there's no expiratory reserve capacity. There's expiratory reserve volume. Which arrow? Because you've drawn two arrows.
So
this one is right. This one is expiratory reserve volume. That's fine.
This one?
Mm-hmm.
This is the one where it's the amount of air, the maximum amount of it, because there's that air that is still in your lungs that you can't expire. I don't remember the name, but I know that's what.
Can someone jump in and say the name?
Residual volume.
Residual volume.
Then you have the whole thing.
Mm-hmm.
That's total lung volume. So it's the amount, like total air you move in and out of in your lungs.
Good. It's total lung capacity.
Okay.
Okay. And there's one missing. Can anybody jump in with what's missing?
Functional residual capacity.
Functional residual capacity. Esmeralda, do you know where to draw that one?
It's expiratory reserve volume and reserve volume.
Right. So it's not going to go up here into the tidal volume. It's going to start here. There you go. Functional residual capacity. Good. Okay. Any questions on that one?
Do we also have expiratory capacity?
There's no expiratory capacity.
Oh, I just made that up.
Yeah. Logically, I think there would be. That's what, but they don't use that term. Functional residual capacity.
When you ask this question on the test, we're just gonna be describing each one, or?
Yeah, so it'll be mostly the terminology. So either I'll give you a definition and you tell me what lung volume that is, or I'll give you a lung volume and you tell me the definition. Yeah, that's most likely how I will use this. Okay, any other questions on those? Okay, so let me talk, we're out of time, so let me just give you a little bit more information about the test. So there is multiple choice. So there's currently about 25, there might be 30 multiple choice distributed among the 3 chapters. So some of the multiple choice are where there's just one correct answer, but if you've taken the most recent quizzes, you know that some of the multiple choice questions have multiple possible answers. So it's not just pick the correct answer, it's pick all that apply. So there are some questions like that. And in that case, I believe it does give partial credit. If there are 4 possible correct answers, 4 answers are correct and you pick 3 of them, it gives you partial credit. But to get full credit, you have to select all the ones that I select. Okay, so some of them are select one answer, some of them are select all that apply. There are some fill-in where you'll have blank and you need to type in the answer. In those cases, your answer needs to match mine exactly, which means the spelling counts, and it does not give partial credit if it's the right word but spelled wrong. So that's being graded by the computer. So you have to spell that correctly. Capitalization won't matter, but the spelling will. Okay, and I tried to only use those on terms where there's not a lot of, you're either getting it right or getting it wrong with the word, and you're either spelling it right or spelling it wrong. There are fill-ins that are drop down, so you'll click on the arrow and it'll give you choices of which word you want to put in the blank. There are matching, and if you've taken the practice quiz with the lockdown browser, you have some of these on there as well, where it gives you a word on one side and then you select from the right side which word matches it. And everybody's going to get, well, different people will get different questions. So for example, I created about 25 multiple choice questions for chapter 5, and everybody's getting 10. So different people will get different questions. Okay. Then there are calculation questions where I said it's only a numerical answer. So you'll just put in a number. You won't be showing your work. You can do your work on the computer. You can do your work on your paper, but you'll only type in the answer and there won't be a unit on it because it's just a numerical answer. And there's a range, a small range within where that number will be accepted. And there will be short answer questions where you just have a box and you just type in your answer in complete sentences. Okay. If you haven't taken the practice quiz with the lockdown browser yet, you need to do that. First of all, because it's going to give you good practice questions. Second of all, because it's going to give you practice answering those types of questions on the computer. Most importantly, it's going to require you to download the lockdown browser, which you're going to need for the midterm. Okay, and that takes a couple of minutes. So when you come in for the midterm is going to open at 12:30 and close when class is over. So if you're spending the first 5 minutes downloading the lockdown browser, you're not going to get to make up that time. Okay, so you want to already have the lockdown browser downloaded when you come in to take the test at 12:30. Okay, I'll probably let it open up at maybe 12:28, and then I'll have it close. You have 75 minutes for class time, and then I usually give an extra 10 minutes after that, so you'll have 85 minutes, and then it's going to close. So if you start 10 minutes late, it's still going to close at the end of class. Okay, so come on time, already have the lockdown browser downloaded. So you'll be on your computer or your laptop or whatever you have on your lockdown browser. You'll have your phone also on Zoom. That way I can see you and you can ask me questions. So everybody will be muted. If you want to ask a question, you'll just unmute yourself and ask a question. It's slightly disruptive, but I've decided I'm okay with that because I think everybody will want to hear your question and the answer. Okay, if we decide after this midterm that's happening too much and it's too disruptive, I'll just disable that. Okay, you will not be able to message each other on Zoom during the test. I've disabled that. Okay.
Is it the same Zoom code for this class?
Same Zoom code, yeah.
Okay.
Okay, so also, if you've experienced the lockdown browser quiz, you know that it gives you one question at a time. You cannot go on to the next question until you've submitted an answer to that question. And once you submit an answer to the question, you cannot go back. So you have to answer the questions one at a time in order. Okay.
That's how it will be for the exam as well?
Will be for the exam. And then when you're done, I believe it will give you your score for the questions that are graded by the computer.
Wait, so we can't like finish the exam and then go back and make sure like we had
Cannot
one
go
that we
back.
weren't sure about?
No, you
Oh
cannot.
my gosh. Okay.
No. Once you answer a question, you cannot go on until you answer a question. And once you answer the question, you cannot go back to it. Okay. So I believe when you're done, it will give you your score for the questions that are graded by the computer, but it will say some questions have not been graded yet because the short answer questions I have to go in and grade. So I think what I'm going to do is I'm going to count up the points for the questions that will be graded by the computer so that you'll know that your score will mean something to you. Because the total points I think is like 128 or 130 on the test right now. And if it tells you you got 100, you're not going to know what that means because you don't know how many points that part was worth. So I'm going to count up how many points that was worth so you'll know what that score, how well you did on that part, and then you'll just have to wait till I grade the short answer to get the rest of that grade. Okay, and I believe it notifies you when once I grade it. Okay, and I'll get that done as fast as I can, but I do have about 200 students, and you guys have never taken a test this way. I've never graded a test this way, so I don't know how long it's going to take me, but I'm going to make an effort to get it done as quickly as possible. Okay.
Do you know the time for the test in total?
The time? Well, your class time is 75 minutes, and I will give you an extra 10 minutes, just like I would if we were in class. So you'll have 85 minutes, but it's going to start at 12. It's actually probably, it's going to start at, I'm going to count the 75 minutes from the 85 minutes from 12:30, but I'll probably let it open at 12:28, just to give you that time setting everything up.
Okay,
So
and for
you might want to set up early, get your Zoom going early because you don't want to mess with setting up the Zoom during your test time. So set up your Zoom first so that you're ready right at 12:30 to go and open up the test. Zoom should be set up, lockdown browser should be set up, you're ready to go.
And we won't be able to access the browser on the computer until you open it?
Until you shut the test down.
Oh, okay.
You won't be able to browse on your computer on any other websites until you close the quiz.
No, I meant to, like, when you know, when do we click to start the test, we're gonna be able to start it until you open it, or?
Right, you won't be able to start it. I'm not gonna make it available until like 12:28.
Until, okay.
Yeah, today's
Okay.
Wednesday, right? So your test is Monday.
Right.
So I'm gonna open it at 12:30, or I'm thinking about 12:28. That's when it'll become available. You'll be able to click on it and start taking it. And then it'll be timed to close at a certain time. It will no longer be available. So you got to take it during that time.
Okay.
Okay.
So, thank you so
If you come
much.
up with other questions, you can always email me. I'm doing this review still 2 more times, and we didn't get to all the questions. So if you want to come to another review, you're welcome to. I'm giving it tomorrow morning at 11 and tomorrow afternoon at 4. I'm giving this review again if you want to come.
Oh, that's good to know. Thank you.
And code. And I'm also doing another workout tomorrow morning. I'm live streaming another workout tomorrow morning at 8:30. If you want to come to that, I'll send out the code. Okay, I'll stick around for a minute or two if you want to stay and ask me a question. Otherwise, have a good weekend. Good luck studying. Go to workshops, go to office hours, go to review sessions, Zoom with each other, study together.
Professor,
You don't need to raise your hand anymore. Just jump in with a question.
So on the practice quiz, it had questions from the last exam. Would that be a possibility on this exam?
That was, I didn't do that on purpose.
I mean, it had questions about like lipolysis and stuff like that. So.
Yeah, no, I don't think, no, I don't think so. I mean, I can't avoid using some of that information because it's connected, but I'm not going to specifically ask questions on those enzymes or anything that was specifically from that chapter. Yeah. When we get to the final, we will. Yeah. Ariel, you have a question?
Said we were going to be unmuted during the exam.
You're going to be muted. Everyone will be muted, but if you want to ask a question, you can unmute yourself and ask a question, but everybody's going to hear it.
Are we going to get in trouble if people come into our area? Like if my kids barge in because I'm sure they will. Like,
If it's your kids, it's fine.
Okay.
If it's your kids, it's fine. I mean, if it's somebody from one of my other sections coming in and whispering answers into your ear, that's gonna be
no, I'm gonna threaten their
I'm
lives.
pretty sure your
But
kids aren't coming in to talk to you to tell you all the secrets about epinephrine. So you
highly
can't-
doubt that one.
I have a question. For the practical exam, there was like one question that it was just completely blank.
Yeah, so this is me trying to figure out how to set up those kinds of questions. So that was an error, which there are a couple of those in my first draft version of the exam too. So I'm going to try to get rid of those to the extent I can, but you guys aren't going to be faulted for those. If there's an error like that, I'll make sure it's not taking points away from you. Because I know there are some blank questions on there.
Does Zoom have to be on our phone, or can it be on the same thing we're taking the tests on? Same device.
You won't be able to run Zoom while you have your lockdown browser on.
Oh, right. Okay.
I had a question about the Chapter 5 study guide. There was a question about what % of VO2 max is due to heredity. I don't know.
25 to 50%.
Thank you.
London, go ahead.
I'm gonna try to share screen just to see. I don't know why it didn't. Let me see.
What did Eddie?
Okay, so you're just showing us your recent documents. So just
Yeah, I don't know.
There should be a whiteboard option. Is it really not coming up for you?
Yes, it says, what do you want to share, desktop or application? And then it has the Zoom thing that I'm on now, and then it has my Google Docs. I don't know why.
I don't know why either.
That's so weird.
Because for me, it opens up everything that's on my desktop to let me choose from, but it also has a whiteboard option.
I think there was a recent update to Zoom. I don't know if you need that.
There was. I did it right before class started.
Oh, okay. Then I probably will do that. Okay.
Might be messing with you. I don't know. Hopefully that's it.
Okay.
Tatiana, you have a question?
Yeah. I didn't get what the formula was for peripheral resistance.
Length times viscosity over radius to the fourth.
Okay.
What did so you gave an answer. It was 25 to 50% due to heredity. What was the question to that answer?
Baseline VO2 max. 25 to 50% of baseline untrained VO2 max is due to genetics. And that involves lung size, muscle mass, blood volume, all of those things are genetics. We didn't talk about, in this review, BMR and RMR. Make sure you review that. The cause of fatigue in the other systems. What else do we not cover? Inspiration and expiration, how those work. Extrinsic control of heart rate, we didn't review.
Professor, can you go over the laws again?
Sure. So Boyle's law is an inverse relationship between pressure and volume. We applied that one to inspiration and expiration.
Does this pertain to the respiratory membrane, the drawing, or no? Has nothing to do with that. Okay.
No, this was before we did that. We were talking about inspiration and expiration. As you contract your diaphragm, lungs expand. That's an increase in volume, which causes a decrease in pressure. So that's where we apply Boyle's law, inverse relationship between pressure and volume.
Okay.
Causes that pressure gradient, which causes the air to move. Okay, then when we had the respiratory membrane and we were talking about pulmonary diffusion, that's where we had the other laws.
Okay.
So Henry's law talks about gas dissolving into liquid in proportion to the partial pressure. Fick's law talks about the rate of diffusion being proportional to the surface area and the gas gradient. And then Dalton's law talks about the partial pressures. So some of the partial pressures is equal to the total air pressure.
Okay. Okay.
I had a question just to verify. So all the charts are pretty much going to be given. We're just going to have to explain them.
Yeah,
and
you
what
won't
they
be
are?
able to draw anything,
Okay.
unfortunately. I normally have a lot of drawings on this test, so. It's still helpful. It's still a good idea to be able to draw them because I think it helps you understand them, and also because you're going to need them in 446. All those drawings come up in 446.
Okay.
On the exam, is there anything that we can abbreviate, like the first exam?
Well, you can abbreviate all the same things you abbreviated in the first exam.
Okay.
So, but you can't abbreviate any of the new terminology.
Okay. So it's just like the ATP and the ions, right? Okay.
I did have another question. You know how you said if we didn't have, like, if we didn't write it the same way you wrote it, so like if we were to write epi and norepi, how would you?
You have to write out
Spell it
epinephrine.
out? Spell it out?
Epinephrine.
Okay.
And you can't do SC, and you have to write out sympathetic cardiac nerve. And like, for example, if we're talking about the venous return mechanisms, I ask you to name the venous return mechanisms. Say skeletal muscle pump. Skeletal muscle pump. I actually think I put muscle pump in there as well, if you just put that, but you have to call it the same thing I called it. You have to use the terminology.
Okay.
But Professor, can you go over the myoglobin saturation curve?
I can. These are not my office hours, but
Oh, I'm sorry. Never mind.
okay. I don't mind. I don't mind.
Okay.
My whiteboard.
That'll be my last question. I'm sorry.
That's okay. Here, all drawings. Myoglobin saturation curve. Okay. So here, it's always going to be PO2 down here. Up here will be percent
of hemoglobin saturation.
And this one is just saturation because there's going to be a hemoglobin curve and a myoglobin curve.
Okay.
Okay, so you put low, medium, high on each of those. And then this will be the hemoglobin saturation curve, which says as PO2 decreases, hemoglobin saturation decreases. Okay, but myoglobin responds differently. As PO2 decreases, myoglobin saturation stays high until the very end when it reaches the mitochondria when it releases it. So this is the myoglobin saturation curve.
Okay.
So so this says as PO2 is decreasing, myoglobin saturation stays high as hemoglobin saturation is decreasing. So if hemoglobin's releasing its oxygen, myoglobin's picking it up. That allows myoglobin to deliver the oxygen to the mitochondria in the exercising muscle.
Okay. Thank you.
All right, any other questions? All right, have a great day, you guys.
No problem. I'm gonna try to go to your Thursday.
I have office hours at 3 and then class at 4.
Yeah, I'll do that.
Okay, awesome. See you then.
Thank you. Bye bye.
Thank you.